Right, Dennis, there you've just basically experienced and witnessed a four-cylinder engine and how it works, basically with the four pistons moving up and down and allowing air and petrol to fuse into a chamber which causes combustion and basically allowing rotation, and that is due to the cam that is basically situated right at the top, allowing these two valves or the different valves to open and close. So welcome to our module 4, which is mechanical Loci cams, and we will be looking at how we are going to draw cams in 2D format and according to the instructions which will be given to us. And basically what we need to understand at grade 11 level is that there are two components which are imperative for us to be able to draw in cams, and I simply want to go through it, what those two items are, which will be asked in different types of assessment based questions. And those two would be a cam displacement diagram, which is basically a graph which is in linear format, and then we must convert that linear format into a rotary format, which is going to be your cam profile. Let me give you a quick sketch of what I'm talking about. So on this blank sheet of paper, you are going to be requested to draw a graph which is going to basically look like that, and the graph will be divided into 12 spaces like that, and each of the spaces that you will have will be 30 degrees, and this will be in millimeters, the height of the cam displacement diagram, and you will have equal spacings of 30 running right to 360, which is one revolution or one circular motion. So that is basically where we are going to start, and you have to plot this cam displacement diagram with basic information given to you. So it will start there, go up to the top, and it will decline again to its origin, which we will find here. The information will guide you as to how you need to draw that cam displacement diagram. Then from there you will have to draw a center point where you are going to have various circles here, and you will have the divisions of the different parts also in 12 spaces, and then you will plot each of these straight line points onto this linear where you are going to have these spaces here also marked as 30s, 60s in spaces of 30 degrees right around till you get 360. Alright, and then you will plot it here on the various lines as it represents each of these lines over here, and then those points will be connected, and that would form your cam profile drawn from the cam displacement diagram. Alright, so let's go through to the first activity and see how we can get the information to be able to draw what is required of us to do. In this first activity, which is a sub-activity of the module 4 of Loci cams, because we have a B activity here, which we're going to look at a little bit later. So if you draw your attention to the given information and the instructions here on your top right hand side, you will find that it states in bullet 1 that the displacement graph of an industrial cam has been given to you. There is the cam displacement graph already given to you. Let's examine what that cam displacement graph is like. You're going to find that it is a box, and the box has been divided into 12 spaces if you count it like that, and each line starting at 0 has been labeled spaces of 30 degrees, 30, 60, 90 and so on until you get 360, which is one revolution. This is your rotation that you will find here at the bottom with your degrees. that vertical upright there is your actual displacement of the actual valve, which will be undertaken by the cam profile. So as we go to our next bulleted point, it says here the minimum cam radius is 10 millimeters. So we're going to look at that minimum cam radius, which is going to be 10 millimeters, and we're talking about a radius here from center point to the circumference. And then the cam rotates in a clockwise direction. So a clockwise direction is going to be as the watch, like that. Clockwise it will rotate. The instructions also tell us that we need to project from this cam displacement diagram and draw the cam profile that would generate to the given motion. Indicate the degrees on the cam profile. The arrow indicating the direction of rotation must be shown. Right? Show all necessary construction when you are going to be unfolding the cam profile from the given cam displacement diagram. So just to reiterate, cam displacement diagram, and from here we're going to convert this to a cam profile. I'm going to take you through this activity step by step so that you can see how this is going to unfold. Firstly, it's very important to identify where the line actually crosses the degree line, and I'm going to dot it. So that's your first point. It's right at the bottom. That is your second point. The line crosses at that specific point through the degree line, and I'm going to plot each of these points very clearly. Here you can see that it doesn't go up or down, so it is stationed or it idles. Those specific words, synonyms, are used for when the cam displacement diagram does not move up or down, or if there's not any movement. There is my next specific point. That is my peak. 1, 2, 3 of the points will peak at the height of my displacement diagram, and then it declines back to its origin. So 360 basically, and 0 would be the same point. Starting point, finishing point. And all your intermediate points I have marked clearly. Immediately after I've plotted my points clearly on here, I'm going to draw a line from the bottom of my cam displacement diagram faintly across like that, and then I'm going to create a line perfectly in the center of this space here, very faintly like that, right down. And this point is going to be important at this stage because I need to use my minimum radius from here down. So minimum radius means that I must be able to draw a circle in here with a center that's there. So I'm going to measure 10 millimeter radius down. So there is going to be my 10. And I'm going to draw a circle in that space over there from where I've marked my specific 10 millimeter radius point. And for that I can either use my compass, putting my center point on that specific point which I marked down, and my pencil point on that top point, as you can see here. Anchor it nicely, and you are going to draw a circle like that there in 2 halves, perfectly like that. Alright, what I'm also going to do is I'm going to bring across my top of my cam displacement diagram in a similar way that I did with my bottom of my cam displacement diagram to this point over here, and I'm going to draw a circle from this center point to form my maximum radius using my compass again. So I'm going to take my compass on the same point, open it up to that specific point over there, which is my maximum radius, my minimum radius, because this is my minimum point of my cam displacement diagram. That's my maximum point. And then I'm going to draw a circle like that there. Of course, very faint, just to go over it so that you can see. There we go. Then the next step is I am going to divide this into 12 spaces, similarly like the 12 spaces on my cam displacement diagram. For that, I'm going to use my 30 and 60 degree set square through my midpoint. That's going to be my midpoint, so there's my first one. At 60 degrees, I'm going to turn it, move it up on my T-square and draw another division like that there. I already have the 2 now, so I'm going to turn and flip it to the other side and draw 30 degrees to that side there. And then lastly, I'm just going to draw a horizontal line from there to there. And now if you check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I am going to do though is just erase this line, not to cause any sort of confusion there. Right. The next step is going to be that the top center here is going to be my 0 point slash 360. It's my start and my finish. It however says here that the cam will rotate in a clockwise direction. There it is in our instruction. So you are going to either put the clockwise arrow here, like that there, or you can put it on the outside of your maximum cam displacement diagram like that, but it must be clearly visible. So your cam is going to turn like that. It is very important to understand when you are going to label this cam profile in the same way that we label the cam displacement linear diagram. But this very important fact, you need to understand that if it says that it will rotate in a clockwise direction, you have to label this in an anti-clockwise direction, meaning that you're going to start 0 there, 30 on this side, and you go counterclockwise to the arrow. That's going to be 60, that's going to be 90, 120 degrees, 150, 180, 210, 240, 270, 300 and 310, and back to 360 at the top. The next procedure would be then to convert all these linear points onto my rotary motion cam profile here. If you start at 0, you will take 0 right across, and 0 will be right here. You can plot 0 there. Now I go to 30. 30 crosses there in my incline motion. So I'm going to move this up, my T-square up to my 30. I'm going to project the line across like that onto my center here. And then I'm going to use my compass from the center point there and transfer that over to 30. So my transfer is just going to be a quick one from there to there. They have transferred that. So that point now is going to be my 30. Then I'm going to go to my 60 point, project that onto my center line there, take my compass, put it or anchor that on my center point, and from there I'm going to transfer that over to my 60 there, and there's my 60 going to be. The same I'm going to draw with my 90, my 120 and my 150 are all on the same line or in the same line. So I'm going to project that across onto my center point, and the three values 90, 120 and 150 will be all on the same line. So I'm going to anchor it there, stretch my compass and project that 90, 120, and then you have your 150. So those 3 points will be in the same line. I'm going to clearly mark them. I go to my next point, which is going to be my 180 point, project that across, there it is, take my compass, anchor it in the center, stretch it to my 180 point and transfer that over to my 180 point, which is going to be right there. Now I'm going to go to my next point. I'm going to find the pinnacle of my cam displacement diagram. I have 3 points in the same line. I've got 210, 240 and 270. I don't need to project it across. I have it already. It's completely situated on my outline, and I'm going to just find where the points are going to be. 210 is going to be there, 240 is going to be there, and 270 all on the same outside line. And then it comes down to my origin, and it first crosses to 300. I'm going to draw from the crossing of 300 across onto my center, and then I'm going to project using my compass, stretch it to that point over there. This time I can actually go around this way, converting it that way there, or transferring it that way there, that way around. That is the point that I need on my 300. And then I go to my 330. I find that it coincides with my 60, so it is there already. All I need to do is to transfer that from that 330 point onto my 330 line, which I have here, and I'm going to plot that point as my 330 point. These are my 12 points now which I've plotted. All I have to do is very faintly start at 0 and draw a line that basically goes through all points on your construction of your profile, very slowly, making it nice and curvy like that there. Once I have that, I need to go over it again, making it nice and dark. Freehand. This is the only part of the drawing which will be drawn freehand, very neatly. This last part is the only part that will be drawn dark. All the other parts will remain faint. And that, my dear boys and girls, forms your cam profile generated from your cam displacement diagram. Learners, please make sure that you stop the video intermittently to do it part by part as it unfolds. We now turn our attention to the B section of our activity. In this particular instance, you are only going to draw the cam displacement diagram by using the given bulleted points, and that's very important, because once you have that cam displacement diagram, you can surely convert that linear movement of your cam displacement diagram to the rotary motion of your cam profile. So in this first instance, it was given to you. Now we are going to create it from the given bulleted points. Let's start in this space over here. So I'm just going to clear that as part of that drawing. So what I'm going to do is, because I'm only going to draw this here, I'm going to draw that line and this baseline here. So I'm going to start quite low. So there's going to be my baseline, and I'm going to use my T-square and Z-square to draw a horizontal line like that there. That is obviously going to be 0 degrees. So if I read through my instructions here, that is going to be when I'm going to plot. I'm going to focus on the instructions. It says here, draw to scale 1:1 a displacement graph with a rotational scale of 360 equal to 100 millimeters and a follower displacement scale of 1:1 for the given motion. The 1:1 is just basically up, that's normal dimensions. Here we have to have a scale of 360 equals to 100. So you are going to put your 0 on this 0 degrees there and measure 100, right? Like that there. And it is important that within the space of 100, you need to have 12 spaces like that, and each label them as it is labeled here in the first instance. So what you need to do is a bit of a calculation. You need to say that 100 divided by 12, and you need to get an answer which is going to be your spaces in between to form your 12 spaces for the displacement diagram. That answer is going to give you 8.3. So what you are going to do is you're going to take your ruler and you're going to open up your compass round about 8.3 on your, it's very difficult, so somewhere between the 8 and the 9 you're going to have your compass opened as a radius. So I'm going to take my 8.3 and I'm going to cut off on my line here spaces of 8.3 12 times. I'm going to carry on like that till I get to my 12 points. And there I've created my 12 points. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I am now going to take my 12 points and project lines up very faintly like that. So I want you to do that as well. Project all the lines up faintly. Okay. There I've drawn all my lines vertically to the top. It's obviously done faintly. I'm now going to label all my points right up until 360 in this exact same way which I have it here. So I'm going to say 30, 60, and I'm going to carry forth, and I'm also going to write here cam displacement diagram. Those are very important. Let's do that quickly. There I've labeled my degrees along the horizontal axis of my cam displacement diagram, and I've also labeled my cam displacement diagram by writing it between two 5mm lines and my scale of 360 equals to 100 millimeters. We don't have the height of the cam displacement diagram yet, but we are going to go through the bulleted points and eventually that height will be determined. We go to our first bulleted point. It says here that the cam rotates at uniform velocity. That word uniform is very important. The word uniform means that it moves through the cam displacement diagram in straight line format. I want to reiterate, uniform means in straight line format. The second bullet says over the first 60 degrees, and you will see that 30, 60. The follower rises by 24. So you're going to have over the first 60, you count 30, 60. It's on this line over here. It rises to 24 millimeters. So I'm going to take my T-square and set square and just cut off 24 and dot that point there. Immediately I'm going to draw a straight line from the origin of 0 to that 24 mark on this 60-degree line. My next bullet says there is a dwell, the word dwell period for the next 30. Dwell means it doesn't go up or down. There's no movement at all. So the dwell period is for the next 30. So 60 plus 30 gives us 90. So merely a straight line as a dwell period or station period, or where there is no movement at all. Our next bullet says over the next 30, meaning from 90 to 120, the follower rises a further 27. So on this 120 line, and I'm going to just briefly just draw a faint line like that there, and I'm going to measure from 0 to 27 over there, and that would be on my 120 line. I'm going to draw a uniform line from there to there, as my bulleted point stated, from the 90 or another 30 to 120, it rises another 27. I go to my next point over the next 60. 60 would be 2 jumps from 120 to 180. That is 30 and that's 30. The follower then rises a further 34 millimeters. So over the next 2, which is going to be here, so I'm just going to draw a faint line just to indicate my movement and keep track of my movement. From there it's going to be another 34. So I'm going to measure from 0 there, another 34, and 34 is going to be right there. That is going to be my point that I see there, and I'm going to draw a line from there to there. I go to my next bulleted point. It says here clearly there is a dwell period for the next 45. So the dwell period means it just goes straight, there's no movement. But for 45, that means it's 30 up until 210, and half makes 45, which is 15. So what I'm going to do is I'm going to draw a straight line like that. So for 45 means that it is going to be 30, there's the 30 degrees, and 45, the difference between 45 and 30 is 15, and 15 would be halfway there. You can either gauge it or you can measure that, which is going to be literally 4 millimeters, and I'm going to draw a line to that specific point over there. My next bullet indicates that over the next 60, the follower descends. Descends means it comes down by 50% of the displacement. Now, here we need to do a bit of a calculation. We have here a rise of 24, then 27, and then 34. So we need to add up all of that to be able to say what my complete height is. And if we do that calculation quickly, we're going to get to an answer of 85. And if you drop or descend by 50%, you need to divide it by 2, and that's going to give you 42.5. And we are going to measure 42.5 down. So I'm going to measure 42.5 perfectly down. It's between 42 and 43, like that there. That is my point there. But I need to understand for the next 60. So that's going to be 15 there, and then a 30, which is 45, and then in the middle is going to be the next point, which is going to make up 60. So 30 is going to be in the middle here, and 15 and 15. So I need to bring this line down in the center like that there, and wherever the 42 is going to meet up horizontally with that point, and I need to connect that to that specific point, which is the 50% drop that I have. Let's go to my next bullet. There is a dwell period for 15 degrees. So you have 15, which is that little space there. That brings us to 300 degrees. That's the 15 dwell period. And then the last bullet states, over the final 60 degrees, the follower returns to its original position. So from there, it drops straight down to 360. So I'm going to draw a line from there to there, dark. Now you'll see that these lines are all dark. Those are the only lines which you are going to draw dark. And should you draw a cam profile, this is the only line which will be dark in your cam profile. Right, there we have concluded the cam displacement diagram from the given information which we have in our bulleted point.